Okay, let's dive right into this. Welcome to today's Explainer, where we're embarking on a pretty fascinating journey to understand a massive, game changing shift happening right now in artificial intelligence. We're going to look at exactly how AI is evolving from what was basically a static, sometimes unreliable parlor trick into a dynamic, highly capable reasoning agent. So, let me ask you, have you ever been confidently lied to by ChatGPT or another large language model? You know the drill. It gives you this beautiful, incredibly articulate answer that turns out to be completely 100% wrong. Well, this happens because standard AI models rely exclusively on their static pre-training data. Once they finish that training phase, their knowledge is literally frozen in time. They don't actually know what happened in the news yesterday, and they definitely don't have access to your private company data. And when an AI hits the very edge of that frozen knowledge, it hallucinates. It's essentially like a brilliant, straight A student being forced to take a closed book exam. When they don't know the specific answer, they just guess. And they guess with absolute, ultimate confidence. Because they're trained to sound fluent and articulate, those guesses sound incredibly convincing, even when they're entirely made up. To make sense of this whole shift, we're framing today's explainer around a simple roadmap: the what, the so what, and the now what. We'll start with the AI memory problem, explore what RAD actually is, look at the recent agentic evolution, discuss the real-world impact, that's the so what, and finally wrap things up with the now what, looking ahead at future frontiers. All right, diving into section one, the AI memory problem. To stop AI from hallucinating and blindly guessing on that closed book exam, we essentially need to hand it an open book and give it a live internet connection. It absolutely needs a reliable way to look things up before it speaks. Back in 2020, researchers, most notably Patrick Lewis and his team, actually solved this memory problem by bridging two distinct concepts. They combined the AI's internal parametric memory, which is just the static knowledge baked right into its neural network weights, with external, non-parametric memory, like an external database or a live text corpus. And this was a huge deal. It meant the AI could suddenly fetch on-demand, up-to-date facts to ground its answers in actual reality. And that breakthrough brings us right into section two. What actually is RAG? This brilliant combination of internal smarts and external knowledge fetching became known as retrieval augmented generation, and it really is the ultimate fix to the AI memory problem. And this brilliantly illustrates how it works behind the scenes, operating in three really simple, essential steps. First, retrieve. When you ask a question, the system actively searches an external database for relevant documents. Second, augment. It takes those documents and inserts them directly into the AI's prompt. And third, generate. The AI reads that retrieved context and generates an answer grounded entirely in the provided facts, not just its training data. Now, as a quick aside, the acronym RAG isn't exactly the most glamorous name for such a groundbreaking piece of technology. Patrick Lewis actually apologized in an interview for the unflattering name. He admitted they fully planned to come up with something better before publishing their seminal paper. But, well, they simply ran out of time and no one had a better idea. It's just a great, funny reminder that behind all this complex, high-level science are real people working on tight deadlines. So, RAG was born in 2020 primarily for open domain question answering. By 2022, we saw massive scaling and specialization as developers started fully realizing its potential. Then, by 2023, the explosion of large language models demanded much better, more robust memory integration, which officially married RAG to these massive neural networks. And now, here in 2025, we've outgrown simple lookups. We have entered the era of agentic RAG, moving from basic fetch and read tools to autonomous cognitive systems that actually reason. Moving smoothly into section three, the agentic evolution. We're entering the so what phase of our framework here because a new problem quickly emerged. As brilliant as standard RAG was, its static, linear pipeline just wasn't cutting it for complex, real-world tasks. You see, early RAG was essentially a naive lookup tool. You ask a question, it fetches the top few paragraphs, and it generates an answer. Boom. But what if the answer requires connecting dots across 5 completely different documents? Or what if the most vital piece of context is just slightly outside the top search results? Static RAG simply fails when faced with deep, non-linear research questions. To fix this massive limitation, the pipeline had to evolve. Traditional RAG is a static single query fetch. Agentic RAG, however, embeds an autonomous AI agent right into the pipeline. This agent actively manages how it gets information. It can plan out a research strategy, critique its own retrieval results, realize it completely missed something, reformulate its search query, and fetch more data before it ever even shows you an answer. Now, what's really interesting about this is how the architecture to make it happen varies wildly. We have corrective RAG, which essentially acts as a bouncer, adding an explicit evaluation step to grade document quality before generation even happens. Then there's self-RAG, where the model generates special tokens to critique its own retrieval live in real time, deciding if it needs to look again. And then you have graph RAG, which maps documents into complex knowledge graphs, allowing the AI to actually hop between concepts and perform multi-step reasoning across vast, disjointed datasets. Which brings us to section 4. So what? The impact. Why should you care about these complex, multi-layered architectures? Well, because they are completely changing the reliability, the scalability, and the security of enterprise AI across the globe. And these aren't just theoretical research papers, folks. They are powering major domains securely right now. The PGA Tour uses RAG to power incredibly enhanced information retrieval for complex historical golf statistics. Bayer uses it to synthesize massive unstructured agricultural datasets into actionable insights for farmers. Rocket Companies integrates RAG to securely speed up incredibly complex document-heavy mortgage processing. And AI companies like Cohere are constantly advancing how these models perfectly cite their sources so that enterprises can actually trust them. This completely shifts the stakes for how we build AI. With Agentic RAG, a modest-sized, highly secure model can literally rival the performance of a massive, super expensive closed-book model. And most importantly, it offers verifiable provenance. We can actively mitigate those hallucinations by forcing the AI to ground its outputs in auditable, proprietary data. That means no more spending millions of dollars retraining the core model every single time facts change. Finally, let's jump into section 5, Now What? Future Frontiers. As we look ahead, researchers and business leaders are already facing a new set of immediate bottlenecks as they try to scale up these autonomous agents. Scaling agentic RAG across trillion-token databases presents some pretty incredible challenges. Right now, researchers are working on perfecting multi-hop reasoning across totally unstructured data. I mean, imagine an AI having to read thousands of messy PDFs just to find one specific trend. They're also developing secure, privacy-preserving retrieval, where knowledge bases remain fully encrypted from the AI itself. We're also seeing the rapid rise of multimodal RAG, which doesn't just read text, but intelligently pulls context from images, charts, and even video. And finally, real-time streaming retrieval, which updates the AI's context live, second by second, much like a real-time newsfeed. So to wrap this all up, we've moved from static neural networks to AI that can actively search, critique, and verify its own knowledge. The memory problem is being solved as we speak. So I want to leave you with this provocative thought. When AI can independently research and verify its own facts flawlessly, what will you ask it to build? Thank you so much for joining me for this explainer, and definitely keep exploring.